So right now we are going to extend graphing linear inequalities into systems of inequalities, and we're going to graph these. So again, in the first one, we are going to graph that line, x plus y equals 6. And since it's in standard form, we're just going to find the x and y intercepts. The x-intercept is 6. And to find the y-intercept, take out the x. The y-intercept is also 6. So there's that line. Notice how that boundary line is solid because of the greater than or equal to. That equal to is huge as to whether it's solid or dashed. Now to determine which side of that line to graph, we're going to plug 0, 0 in because that's not on the line. If it makes it true, we're going to shade that direction. If it makes it false, we're going to shade the opposite direction. So is 0 plus 0 greater than or equal to 6? Nope. So we are going to shade that side. Our final shaded region is going to be somewhere on this side of this line. Actually, I just drew arrows to signify that. Our final shaded region should not be down here at all. So to graph the second one, the x-intercept, if we take out the y, the x-intercept is 2. And the y-intercept is going to be 5. And again, it's a solid line. So I'm going to continue this line up and draw this line down. So our final shaded region is either going to be here if 0, 0 makes it false, or here if 0, 0 makes this one true. Now, for the point 0, 0, plugging 0 in for x and y, 5 times 0, 2 times 0, is that less than or equal to 10? It is. So our final shaded region is up in this area right here. That is our final shaded region. Now for B, again we graph the line x plus y equals 4. The x-intercept and the y-intercept are both the same. And since it is just less than, we are going to graph a dashed line. And we can again check the point 0, 0. Is 0 plus 0 greater than 4? No. So we're going to graph or shade the opposite side of that line. So our final shaded region is going to be in that area somewhere. Now, for the second one, x-intercept is 7, which there's 6. 7 would be out here somewhere. And the y-intercept is positive 3. And that one's going to be a solid line. All right. Now, so our final shaded region is either going to be down in this area, if the point 0, 0 makes that second inequality true, or it's going to be up in this area if 0, 0 makes it false. So, is 0 plus 0 less than or equal to 21? The answer is yes. Makes it true. So we are going to be, our final shaded region is right down in this region here. And finally, for the last two examples, again, graphing each line individually. The x-intercept for that first one would be negative 3/2 or negative 1.5. And the y-intercept would be positive 3. Since it's greater than or equal to, we are going to graph a solid line. And we'll check to see if 0, 0 makes that true. Is 0 minus 0 greater than or equal to negative 3? Yes. So we are going to be shading this side of the first line. Graphing the second line, it's in slope-intercept form, so the y-intercept is positive 1, and the slope is negative 1/2. And that one also is going to be a solid line. So, our possible shaded region is either going to be down here. We'll shade down here if 0, 0 makes that second equation or inequality true. Or we'll shade up here if it makes it false. So, plugging in the point 0, 0 is 0 greater than or equal to negative 1/2 times 0 is 0 plus 1. And the answer is no. 0, 0 makes the second one false. So we will shade the opposite side of that line, which ends us up in that little area. And finally, D. Graphing the line x plus 2y equals 4. X-intercept is 4, y-intercept is 2. Since it's less than or equal to, it will be a solid line. And to determine which side of that line to shade, plug in 0, 0, because it doesn't go through 0, 0. Is 0 plus 0 less than or equal to 4? The answer is yes. So our final shaded region will be part of that area down there. And then the second line, it's in slope-intercept form, so the y-intercept is negative 1, and the slope is also negative 1. And so our final region is either going to be here, if 0, 0 makes that second inequality true, or down here if it makes it false. So, is 0 greater than or equal to 0 minus 1? The answer is yes. So that's the side that we will shade. And there is our final shaded region. So that is graphing systems of inequalities, and that is the last section that will be on Friday's quiz.